Hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and today I will show you how to start from scratch a process simulation in Aspen Hysys. In this class I have 3 goals and I will share with you right now. The 3 goals that I have with this class is to show you how to start a process simulation, so I will explain you how is the procedure to start a process simulation in Aspen Hysys. Moreover, we will see how to add a pump to your process simulation and a pipe segment also, and we will see how to set that to our process simulation. And finally, I will show you how to use the pipe sizing utility in Aspen Hysys. It is a technique from the intermediate to advanced, but I believe that what you will learn here, it will be very useful for further process simulation you do. Enough from my face, let's go to the process. I'm here in the start menu of Aspen Hysys V10, but you can use the Aspen Hysys V11 also with no problem, and I will click on New to load a new simulation. And here is where we start doing our process simulation. But before starting, we need to know what is the problem that we must solve. And to do that, I will share with you a hydraulic calculation problem. This pipe sizing hydraulic problem is very popular in LinkedIn. As I know, it was first shared by my dear friend Vijay Sarat, and since then, many people has doing random calculation to solve this problem. And you can see that we have many tasks here to be done, and I will use this only for reference to build our process simulation. So we'll add the pump and we'll add the pipe, and with that we'll calculate the best pipe sizing to match the problem requirements. You can download this problem from my Telegram channel In Process, and to do that you will find the link for In Process Telegram channel in the description of this video, or you can go to my website and there you will find the link to my Telegram channel In Process, and also how to share connection with me in LinkedIn. And moreover, I have a blog where you can find much more information about chemical process engineering and plant design. That said, let's proceed with our presentation, and in this case I will use this problem just as reference because I don't have the composition of the oil. To start your process simulation, the first thing that you should do is add components to your component list. So to do that, you just click on Add, and in this case I will add the propane, and I can click 2 times in the component and it is added to my component list, or I can highlight that and click on Add. So this is the 2 ways that I can do that. I can search for other components, but I will not do that right now. Once you have the components that you want to your process simulation, the second step is to go to the fluid package and add a fluid package to your process simulation. And in this case, I will use the Peng-Robson. It is very popular when you are talking about hydrocarbons simulation. These are the main steps that you must do to perform your process simulation, and you can see that as all folders are checked in blue, you can proceed to your simulation. And if we were talking about reactions in our process simulation, we should add that to the process simulation, but it's not the case. So now, once I have chosen my components to be added to my component list, and as I have chosen at least one fluid package, now I can proceed to simulation. And it is in the simulation that I will build my process simulation diagram. You can organize your screen view. So I like to have the model palette at the right of my screen. I like to remove this because I don't use that. and hide the navigation pane and minimize this here, adjust my model palette, and after that I like to hide it. And moreover, I like to show the toolbar, but in this case I will let this shown to make it easier to us to understand what I'm doing. And I do that because I like to have as many areas as possible to do my drawings. Before starting, I recommend you to choose the correct unit sets to your process simulation. So in this case, I will let the international standard as the main set for the units. And the first thing that we'll do is add a material stream. So I will return with the model palette, and just to make our life easier, let me have it fixed. And we have two kinds of stream here. The blue one is related to material stream, and the red one is related to energy stream. So every time that I need to define composition, pressure, temperature, mass flow, I will use the material stream. And in the other hand, every time that I need to define an energy that will be exchanged with the system heating up or cooling down, I will use the red stream. And let's begin with the definition of a material stream. So I will click 2 times on that. It will open a submenu with a lot of information, but we must use 3 groups of information. The conditions, and per standard, Aspen Hysys will always open your material stream in this group of information. In any case, it will record your last tab that you accessed. The other one is property, and here we don't fill any information. We only get the information that is loaded from the fluid package based on the conditions of pressure, temperature, composition, and etc. And the third group of information that we have is composition. And we will start from here to define our stream. And once I highlight one of these fields, I can digit a number, and another submenu opens, and I can define if my composition is in mole fraction, if it is mass fraction, or it is mole flow, mass flow, liquid volumes flow. And most often we use mole fraction, or in some cases we use mole flows or mass flow. It will depend the objective and the information that you have to build your process simulation. So for this case, I have a mix of 50-50 percentage of components, and we use the fraction. We not use the percentage. And you can see that there is a totalizer here. And every time that you're working with fractions, it doesn't matter if it's small fraction or mass fraction, the total must be 1. However, if you fill the information with a number below 1 or above 1, once you click on OK, the Aspen Hysys will redistribute the fraction in order to get 1 as the final result. So let's take a look. So you can see that it's changed, and the summing up of this will be 1, and it can lead you to errors in your process simulation because you will have a different composition that you were supposing to have in your process simulation. So it is very important to make sure that you are filling correctly the mole fractions of your composition or the composition of your stream. Once I have done that, I can click on OK, and now it is set. And the next thing to do is to add the conditions of my process simulation, and most often we add information to temperature and pressure, and we get the other results related to the properties of the stream. And in this case, I will assume that the temperature is -25 Celsius. And you can see that as I'm using the international standard, the pressure is in kilopascal, but I want to have my process simulation in bar. And to solve that, I can go to the unit set, and instead of using the kilopascal, I can change the units of my process simulation, going to the units of measure and changing the kilopascal to bar. And when I click on OK, the process simulation now converted the information to bar. And in this case, I will consider that the pressure in the vessel A is 1.5 bar. And with that, I have liquid at my vessel A, and the only information that I don't have right now is information related to flow. And I can set the molar flow or I can set the mass flow. And you can see that every time that I have a blue field is something that I can feel, and when I have information that is in black, it is calculated by the Aspen Hysys. So the information about the mass flow I have from the problem, and it is 25,000 kilograms per hour. And the remaining information was calculated by Aspen Hysys. And all this calculation is based on the fluid package that we have chosen, and it is here in this base 1. If you open that, it will address to Peng-Robson, and in the properties you can see a series of information related to the properties of your stream. So this is how you set the material stream, and now let's add the pump. But before I do that, you can see that we have information of volume flow here, and there are different information related to volume flow in Aspen Hysys. And if you want to get more information about that, you can go to my Telegram channel, and I recorded an audio there to explain the main difference between the three kinds of volume flow that we have in Aspen Hysys. So now that we have our material stream, I will add the pump to our process, and to do that, just click on pump. And now I click 2 times to open the submenu. And when I do that, I need to define the inlet stream, the outlet stream, and also the energy stream. Depending on the kind of equipment or object that you add to your process simulation, you need to add information related to energy. And that is one of the differences that Aspen Hysys has related to other process simulators like Symmetry from Schlumberger. So I can choose from a list clicking on the arrow, or I can also define inside the submenu another stream. So I will type 2 here, and when I click on enter, I will create another stream here. And it identifies if it must be a material stream or if it must be an energy stream. As I already have the energy stream at my simulation, I will choose that also. And now I have all connections set, and you can see that the information here in the pump changed from red to yellow, and I have a device here. So it is always useful to you take a look in the devices that Aspen Hysys tells you, because you will have a tip or a clue how to proceed. And what we need to do now is to define the duty, and the duty is the power that is required or the energy that is required to the pump build pressure in the liquid. You go to the tab parameters, and just to show you how it works, let's suppose that we need 2 kilopascal, and once the equipment is converted and everything is okay, the green line appears and you see a device of OK. So in this case, the pump is already converted, but it is not what we want. The problem asks us to define what should be the discharge pressure of the pump in order to get 2 bar G at the discharge of the pump. So I will delete this information because it will be calculated during our exercise, and what I will do now is add the pipe segment. To add the pipe segment, we return to the model palette and we look for the pipe segment. We add that to your process, and doing a double click on that, we need to define the connections, and you can see that we need to define the inlet, the outlet, and we have also our energy. So in this case, I have the inlet as the stream 2. I will create the stream 3 as the outlet, and in this case, my energy related to the pipe, I will call loss heat. So you can see that you can define streams as numbers, but also as names. And to add a segment, we go to the rating tab, and here you click in append segment. So the first thing that you will do is add a segment, and as standard, the segment that is added is a pipe, but you can add other segments and you can change that to T's, to plug clock angle, and it is kind of valves. There are check valves, butterfly valves, and many other kinds of stuffs here. It will depending on the objective of your process simulation. So this is not the case right now. We can delete that, and I will be only with the pipe segment 1. And I have the length defined in my problem. So this is 400 meters. And you can change the unit if you want. Every time that you see the arrow is because you have options to change that. And the elevation is 0 according to the problem, but you can change it also. If your pipe segment is going up, you will define a number here, a positive number, and if your pipe is going down, you will define the elevation as negative. In the problem, we have a reference for the roughness of the pipe, and we will change the roughness of our pipe. And I will just add the same information that I have in my problem. And in this case, we have 45.2 micrometers. And in this case, micrometers is 10 elevated to -6. I don't have a reference to pipe size, and in fact it is what the problem wants to solve, and for now I will let that empty, but I need to define the kind of heat transfer that we will have between the tube and the environment. So in this case I will consider that it will be 0 heat lost, and in this case now I just need to define the pipe size. And to do that, I will use the utility pipe sizing. To add the utility pipe sizing, we need to have a fully specified stream. And to know if a stream is fully specified or not, you can see the color. So if you have dark blue, means that it is fully specified. And if you have light blue, it means that some information are missing. So I will click on these 2 times, and I go to the attachment tabs, and I go to analysis and click on create. I'm looking for pipe sizing and click on add, and I will have a submenu where I can define my pipe sizing according to some conditions. But it will not work in this stream because it is not fully specified, and it is not fully specified because we don't have information related to temperature, pressure, and all the vapor phase. So it is not possible to add this utility in stream 2. So what I will do, I will use the utility 1 because my criteria is related to pressure drop and not to velocity. So to have a reference, I will do a double click here and I go to attachments, analysis, and I create, look for pipe sizing and click on add. And what I want is, according to the item 1 of the pipe sizing hydraulics problem, the question is, what would be the pipe size ID required for a allowable pressure drop of minus than 0.5 bar across the pipe, assuming you found a supplier who sells commercial pipes sizes as per NC-ASME B31.3. So what I need to do right now is get the pressure drop, the maximum pressure drop that I can have, and I will divide that by the length that I have between the discharge of the pump and the inlet of the vessel B, and I will get 0.00125. And I will add this information to my pressure drop. So based on that, Aspen Hysys will calculate the maximum diameter recommended to not surpass this pressure drop. So I have 0.00125, and I will change the unit or the reference that I want, that is bar per meter. And in this case, the Aspen Hysys calculated to me a nominal pipe size of 2 inches. And if I go to performance, related to the velocity, to Reynolds number, and also to the effective pressure drop calculation related to this size of pipe. So what I will do now is add this information to my pipe in the discharge of the pump. I go to alter diameter, and when I click 2 times, I will add the schedule 40 that was in my utility, and I will choose the nominal diameter as 100. And now the only information that is missing is related to the inlet or the outlet of the pipe segment. So what I want to have at the outlet of my pipeline is 2 bar G. So I will add that to my process simulation. And it didn't convert it because we don't have any information related to the inlet of the pipeline. And to solve that, I will use another resource that is intermediate to advanced also, and now we will add the adjusted tool. And what it does. With this object, we can define a dependent variable from an independent variable. So in this case, what I want is to have 2 bar G at the stream 2, and I will set my adjust to get the best result at the stream 2 to have 2 bar G at stream 3. So let's do a double click here. And first, I usually set first the target variable. So my target is the stream 3. And what I want is the pressure. So I select the object that I want, it is stream 3, and I want the parameter that I want, that in this case is pressure. So this will be the source of information to the adjust, and what I want is 2 bar G at the discharge. And my adjusted variable will be the stream 2. Choose stream 2, and it will be pressure also, but can be different variables depending on the process. And what I need to do is click on start to start the iteration, but before doing that, I will increase the number of maximum iteration, because once the Aspen Hysys reach the iterations, it interrupts and ask you if you want to proceed. So I usually increase this number, and now let's click on start and verify if we convert our process simulation. And you will know if it converted if we get the green line here. But before doing that, I will do a guess to Aspen Hysys in order that he identifies what is the starting point. So in this case, I will add as true, but this value will increase once we have the pressure drop in the pipeline. So I will close this window. And another thing that we will do here is delete the information at the outlet of the pipe, because as I added the adjusted, the result will be a function of the dependent variable. So I will delete this. And interesting thing that happened here, you can see that the stream 2 converted and the stream 3 converted, and for the Aspen Hysys, it did the calculation, and we have here that the pipeline is over-specified, but the results doesn't make any sense, and I will tell you why. It doesn't make any sense because we have here 2 bar flowing through to 3 bar, and every time that we have flow of fluids, it goes from the higher pressure to the lower pressure. So this kind of results doesn't make any sense, and this is why it's so important to the process engineer or to the chemical process engineer understand what he or she is doing while he or she is performing a process simulation. It was not my intention to have this result, but it was interesting to comment this to you. So what I need to do now is delete this information, and now I have a consistent information because the outlet of the pipeline is lower than the inlet, but I don't want it. I want 2 bar G at the stream 3, so because of that I need to start the adjusted, and we will see that the stream 2 pressure will increase. So let's verify that. And now we have the conversion of the adjusted, and when I return here, you can see now that the pressure at the discharge of the pump is higher than 2 bar, and it is because we have the pressure drop between stream 2 and stream 3. And with this we were able to define the minimal pump discharge pressure to reach 2 bar G at the outlet of the pipeline. Before I go to the final comments, let me show you a button very useful that we have here. Is this one, is the zoom fit. When I click on that, my simulation fits to my screen, so that's why I like to have most area as possible. So my friend, this is it. Now you learned how to start your process simulation in Aspen Hysys. Moreover, you find how to add a pump to your process simulation and also a pipe segment. And as a bonus, you learned how to add and set the adjusted object. And it is intermediate to advanced technique to convert your process simulation. You can get the PDF file in my Telegram channel in process. You already know how to do that. Go to the link in the description of this video or go to my website jefersoncosta.com. And I encourage you, if you want to know more about chemical process engineering and plant design, to take a look at my process simulation tutorial playlist and also in my video engineering documents for chemical engineers. If you are in my YouTube, both of them are available to you right now. And if you aren't, go to my website, click in the link to my YouTube channel and look for these videos there. So I hope you like it and return to have more related to chemical process engineering and plant design. My name is Jeferson Costa, I'm a chemical process engineer with expertise in plant design, and I'll see you soon in the next video.